Today we're going to go over intermolecular forces. All right, and inter means between. So intermolecular forces are going to be forces between different molecules that hold them together. So here I've shown water molecules, and hopefully you remember that water has a negative charge or partial negative charge on its oxygen end, and then the two hydrogens have partial positive charges. Okay, so the way this is drawn, you can see that the hydrogens line up to interact with the oxygens because that positive charge is attracted to the negative charge. So opposites attract. All right, and there are 4 different ones that we're going to learn about today. Let's start with ion-dipole. So ion-dipole interactions, we have an ion, which has a full charge. So for example, here I've shown sodium. If you remember, sodium has 1 valence electron, which it gives away, and that leaves it with 1 more proton than electrons, and so it has a full positive charge. So you won't see a delta with an ion. The delta means partial, and you just see that with polar molecules. All right, so our positive sodium ion here is interacting with the negative or partial negative side of the water molecules that are here. And you don't see any of the positively charged hydrogens pointing that way because our like charges would repel. Right? So ion-dipole are one of the strongest intermolecular forces because we have a full charge on that ion. And the ion could be positive, as I've shown here, or it also could be negative. So we could have a chlorine ion or chloride ion here with a negative charge, and then all of our water molecules would shift around so that the positive ends would be facing the ion because of the attraction between the positive and the negative. Okay, so the second one I'm going to talk about is dipole-dipole. Di means 2, if you remember, and pole means the ends. So we have 2 different ends, like we talked about with our polar molecules. All right, and because we have those 2 different ends with 2 different charges, they can be attracted to each other. So the Cl could be attracted to the H from this other molecule. All right, and you could get a whole network of interactions like that, like we saw with the water in the beginning. All right, a special kind of dipole-dipole is a hydrogen bond. All right, and one important thing to note is hydrogen bonds are not actually bonds, all right? They are intermolecular forces, or IMFs, okay? And they're just slightly stronger than dipole-dipole, all right? So here I've shown water, which is polar, all right? We get hydrogen bonds, we have hydrogen bonded to either oxygen, nitrogen, or fluorine, okay? If hydrogen is bonded to carbon, it can't hydrogen bond. It has to be bonded to one of these 3. And that's because those are our most electronegative atoms on the periodic table. So they're going to pull the most electrons away from the hydrogen, giving it the biggest possible positive charge without making an ion. All right, and then the last kind we're going to talk about today are dispersion forces. Sometimes I also call these induced dipole. So you have something that is neutral, all right, and it could be an atom or it could be a nonpolar molecule, and the electrons normally are evenly distributed around the nucleus, okay? So there isn't one side that's positive and one side that's negative. It's even the whole way around. But electrons, as we've talked about before, are a cloud, and that cloud can shift, all right? So if it's in some moment in time, the cloud shifts over this direction, over to the right side of the nucleus, we'll end up with a partial negative over here, and a partial positive over here because part of our nucleus is going to be exposed. And remember, that's where our protons are. All right, so dispersion forces are the weakest of the intermolecular forces, but if molecules get really big, dispersion forces can actually be quite strong. And the reason for that is that larger molecules or atoms have more electrons, and so they can more easily shift off-center and create these momentary dipoles that you see here. All right, so the bigger our molecule gets, the bigger the dispersion forces are going to be within that molecule. All right, that sums up the 4 different types of intermolecular forces, and we'll do some more stuff with these in class, but if you need to revisit, you can always go back and rewind and re-listen, and let me know if you have any questions.